Is it on? Is it on? Hello? Oh, I guess we're recording. All right, so the other example that you see in the notes, like it says, try it on your own. Share it with me. Come up to the board right before class starts. Write it on there. I would love that. Give you some feedback, help you not lose points on a quiz or test. And you're sharing with the class, so maybe they're going to get something out of it too. It's all good. So let's just dive in. There are lots of different kinds of partial fraction decomposition. We in this class are only going to be doing the absolute simplest one. But if you're going on to calculus, you're going to get them all like that. So there you go. Let's dive in. So we got step one, factor the denominator. Man, we love these quadratics and factoring. This one, I'm going to do the X method. So remember, scratch work off on the side a little bit, please and thank you. Keep it separate from the solving bit. So top of the X, 4 times 15 is 60. Bottom of the X, the middle term 16. Factors of 60 add up to 16. There you go. All righty. Remember, if there were negatives, I showed you some of that stuff back in lesson dose at the beginning of lesson 2 in this unit. And then actually walk through the factoring. So the X method sets up factor by grouping. Remember, it doesn't matter if you had the 10x on the left or the right, the 6x in front, it's all good. Factor accordingly. When you do factor, if you made a mistake, then what you have in parentheses will not match the 2x plus 5 and then the 2x plus 5 will not match. And you'll know something went wrong. Like when I did this before and then I deleted it, I had 10x plus 4x. Weird stuff happens like that. That's why I tell you about how you can identify mistakes and stuff like that. All right, step 2 is the setup. So you factor that. There's 2 factors, and we are decomposing the original rational expression into 2 separate rational expressions, 2 because there were 2 factors. And as you can see, we use capital letters in the numerator. I've always seen that, A, B. The other video that I left in that's not in the notes has a cube. And if you're curious, you can watch that video, but it's not a part of these notes. All right, the next step is we're going to, as you see, air quote, where's my air quote, solve the rational expression, but we're not solving for x. We're going to use those values, but ultimately we need to figure out what capital A and B are, like that. So we take the least common denominator, we multiply it through by everything. The original expression has the least common denominator, so it cancels. The new expressions with the A and B, whatever's in the denominator cancels, and then the other factor gets multiplied by that capital letter. Like thus. You need the 2x minus 7 on the left. That is important. We are working with an equation. So you have to have that. Now what we want to do here is we're going to substitute a specific value of x that will make one of those factors equal 0. So in a sense, these are the divide by 0 numbers. So if you paid attention to that at the beginning, what value of x makes you divide by 0, those are the numbers that we're interested in because they'll make one of the factors equal 0. So there we go. Oh, I'm talking on I gave you all of this on the other one. All right, so a times that factor, if that x value is negative 5 over 2, then it'll make it equal 0 and a will be canceled out. Therefore, we are solving for b. And this is why you need the 2x minus 7 on the left, because you got to plug into that x value as well. So plug into all 3 of the x values. That specific choice, x equals negative 5 over 2, is canceling the a solve for B, repeat for the solve for A. So take the factor next to B, solve it. X is negative 3 over 2, plug it in, solve for A. And there is our answer, like that. I am, of course, going to show you how to double check. Now, the double checking is very similar to the initial step in this process. So if you make the right mistake here and there, they might kind of cancel out, and you got it wrong, but you think you got it right. So you just got to be a little careful here, like that. All right, so double checked out. I'm gonna stop now.